So I'm Yao-Yi Chiang, computer science and engineering. So my area is mainly working on spatial data. So we work on all kinds of spatial data. And I'm going to show some examples. So this is from the report. Starting from this, I'm going to talk about these pre-trained foundation models, multimodal data, and the language interface. So here's interesting photo. I took that photo somewhere in the world. So geolocating a photo is a very difficult task. And here I'm showing you that we tried the ChatGPT 03 with this prompt to ask GPT to figure out the location. Okay, so this is the result. It says 2 streets that might match the look and feel of your photo, and they are both in Seoul, Korea. How many of you think this is correct? Maybe. So what's interesting about this 03 is we can actually look at how it reasoned about the process. So if you look at the small text here, I know it's very small, but I highlight all this for you. It says the roads looks like Korea with the yellow center lines, with green fences, lampposts, and all these different things. And they also think this is a mountain area because of the hilly road and all kinds of stuff. So conclusion is this is somewhere near a mountain in Seoul. Is this correct? Well, I took the photo, I know the location. This is actually in Busan. But if you look at Busan is also in Korea. But if you look at the reasoning process, it's actually pretty cool. And it actually identifies all these objects correctly. It's just the last part of assembling all this information to do reasoning. It has some bias toward popular cities. Okay, I have 3 minutes. So Google also do some geospatial reasoning work. Doesn't show. Okay, so it's a very short video about how they do the, how they think about this geospatial reasoning. So given some satellite imagery, their large language model and vision model will be able to answer questions like damage assessment, identify buildings from all these images, and summarize the building conditions. So just to speed up, I can show you something like this, right? So this is an interesting example because traditionally you will need someone who has GIS, Geographical Information System knowledge, to look at the photos, identify the buildings. Maybe you can run a machine learning model to identify the buildings and do some analysis. Now they have this approach that they can call their foundation model, get the satellite imagery, so data is the key here, get the building out, and write the caption about the condition of these buildings. Another interesting work that we look at, this is called GeoGPT. This is for geology. So the application will be able to look at geological reports. You can upload maps. It will be able to analyze them, synthesize data for you. Another way, when we look at GenAI with Spatial, this one is very interesting. This one is called Spatial Rack. So it takes existing geospatial data, like map data, OpenStreetMaps, Google Maps, and use that to constrain and help augment our large language model to answer questions like that question, like we are in somewhere, what are the restaurants that we should go? So now we look at all these examples, right? You can see that still handling rare cases would be a problem. Like in the ChatGPT example, it will tell you it's Seoul, but it's actually in Busan. And there are explainability, trustworthy of the result. And the last one is symbolic reasoning is still a challenge. As you can see from that RAG result, you need to have some way to work with the model to be able to generate meaningful and interesting result. Also, people have been working on other types of models, foundation models, Like satellite imagery, people build vision foundation models so that we can take lots of satellite imageries, use their features to do something like this. Oh, somehow my images doesn't show. Oh, okay, it's just slow. So something like this, you can take a satellite imagery, you want to be able to predict for a certain location about the soil condition. You can take those foundation models that's trained from lots of satellite imagery and to do it. You can build language model trained from scratch using map data. But out of distribution data and application is still a problem. Like you train a model for one location, probably not useful for a different location. I think I might just stop here so that